In these videos, we're going to look at the free response questions for BC practice test number 3. So in question 1 here, we have a parametrically defined curve called C. You could see that x of t comma y of t there in the parentheses. They also give you the formula for dx dt, that's the t sine of 2t over 3, and dy dt, which is cosine of t squared over 4. And that's only defined on the interval from 1 to 6. That's going to be significant. You have to remember where this thing is defined and where it's not defined. That definitely will matter. All right, and having said that, now we take a look at part A, find the slope of the tangent line to the curve C at the point where t is equal to 3. All right, so let's zoom in on part A there. Whenever they say slope of a tangent line, whether it is in a Cartesian coordinate plane with a function, whether it's parametrically defined curves or polar curves, when they say slope of the tangent line, they are talking about dy dx. Now, you should remember this, the formula for dy dx for parametric curves. Dy dx equals to dy dt divided by dx dt. And in this particular case, we know what each of those two things are. So you're going to write them down in the appropriate spots. Dy dt gets replaced with cosine of t squared over 4, and dx dt gets replaced with t times sine of 2t over 3. Now this is a calculator active question. So at this point, you can go right to the calculator, just put your functions in, and replace the t's with x's on the calculator. On the paper, you have to use the correct variable and notation, but in the calculator to find a numerical answer, you can just use x. So we wind up with negative 0.230. Now, if it's possible to answer the question in the words of the question, then you should do that. Write a sentence using the same words that they gave you there. So the slope of the line tangent to the curve C at the point where t is equal to 3 is approximately negative 0.230. There's part A. All right, part B is asking what's the value of t at which the line tangent to the curve C is vertical. All right, well, for a tangent to be vertical, its slope has to be undefined. Since the slope is dy dx, and we just saw that formula for that, that means that the denominator, and only the denominator, of dy dx, which is really dx dt, that has to equal 0. And remember again, this is a calculator active question. So there's dx dt, that has to equal 0. Now you've got two factors there. You've got t and the sine of 2t over 3, and their product is 0. The only way you can get a 0 product when you multiply is if at least one of the factors is 0 itself. And remember, t is only defined from 1 to 6. We said that was going to be important. So the t factor cannot be 0, which means the sine of 2t over 3 is the one that has to be equal to 0. Now that happens when t is equal to 3 pi over 2, or approximately 4.712. Because this is a calculator active question, you can just graph y equals that with x instead of t's and see where it hits the x-axis on the interval from 1 to 6. Okay, now the value of t, and again we're just using the wording of the question to answer the question. For the interval from 1 to 6, the value of t at which the line tangent to the curve is vertical is approximately 4.712. All right, on to part C. Find the length of the curve C for that interval from 1 to 6. Well, length of a curve, or arc length for a parametrically defined curve, is given by that formula, definite integral from a to b of x prime of t, or dx dt squared, plus y prime of t, or dy dt squared, dt. Don't forget the dt or the dx if it's in terms of x for other integrals. Right, in this particular case, we know what those two things are. They're already defined as dx dt and dy dt, so I don't really need to replace them. If you feel a little more comfortable using the expressions, go ahead and do that. Just put in your correct limits of integration. They come right from the interval they gave you, from 1 to 6. And then it's all calculator. Go to the calculator and you get that 10.569. And of course, write a sentence using the words of the question. So there's your answer. And now we go on to part D. All right. Now, this one, they don't give you a lot of words to use in an answer, but you don't really need to. They're just asking for y of 3. Now, they gave you y prime, dy dt, and they want y of 3. This is an accumulation function. And remember, with accumulation functions, you have to add your starting amount plus the definite integral of whatever your rate of change is from your starting time to your ending time. And that's important. Now, our rate of change of y is dy dt. So my starting amount comes from the initial condition, y of 1 equals 2. And that means that my starting time, or my lower limit of integration, is going to be 1, because it's y of 1 equals 2. That's my starting time there. So y of 3, the thing they're looking for, is equal to 2 plus the definite integral from 1, my starting time, to 3. That's what they want, y of 3. So that becomes your upper limit of integration of y prime of t dt. Right? Write it as y prime of t dt. That way the dt goes in the place it's supposed to go, and you don't have any confusion writing dy over dt. But either way, on the calculator, when you do all of that, you get that 2.805 if you round, 2.804 if you truncate. Either answer is fine. And that's enough work to show to get full credit for part D. All right, on to question 2. I'll give you a table of values, and then they're asking you to approximate a derivative and do some other things in here. But this is a store tracking sales of a popular board game over a 12-week period. T, the upper row of the column of the table, stands for the number of weeks, or the number of the week, and the rate at which games are being sold is that second row, G of T, and it's measured in games per week, only defined from 0 to 12. If they want to figure out how many games per week were sold outside of that interval, they're going to have to use some other function to do this, or some extension to this. All right, so zooming in on part A, we're going to approximate the value of g prime of 8 using the data in the table above. You want to approximate the value of a derivative, you're going to use the slope of a secant line. Right? Derivative is the slope of the tangent line. When you're given a table of values and asked to approximate a derivative, you're always going to just set up a slope formula for a secant. They want the slope of the tangent, or g prime, at 8, t equals 8. 8's not part of the table, but it's surrounded by, right, the points 6, t equals 6, and t equals 10. It would be right in there. So the appropriate slope formula would be g of 10 minus g of 6 over 10 minus 6. You can do the substitutions from the table, and you wind up with 300. Now, g of t is already in games per week. That means when you take the derivative of that, you add another time component, or if your units of measurement have 2 units, one in the numerator, one in the denominator, you add an extra factor of whatever's in the denominator, in this case, weeks. So it's games per week per week. If you wrote that as games per week squared, where it was just the week that was squared, then that would be okay too. All right, so there's part A. Part B, approximate the value of the definite integral of g of t using a right-Riemann sum with the 4 subintervals indicated in the table, and then you have to explain the meaning of that within the context of the question. All right, when you integrate a rate of change, you figure out how much change has occurred over that interval. We'll get to that in a minute, but let's set up the right-Riemann sum. Our subintervals are from 0 to 3, 3 to 6, 6 to 10, and 10 to 12. And notice they are not all equal width subintervals. So you got to keep track of that as you set this up. So our definite integral of g of t dt from 0 to 12 is going to be equal to the sum of those 4 rectangle areas. Right? And you can see that I'm taking the y values, or the g of t values, from the right side of each of the 4 subintervals, and I wind up with 17,250. Once again, when you integrate a rate of change, you figure out how much change has occurred. So the meaning of this in the context of the problem, it represents the total number of games that were sold over the 12-week period from 0 to 12. And that's part B. On to part C. Okay, one salesperson believes that starting with the 2,400 games per week at t equals 12, that is the last column of the table, right, bottom right, the rate at which games will be sold will increase at a constant rate of 100 games per week per week. So they're talking about another rate of change here, all right? So based on this model, how many total games will be sold in the 8 weeks between t equals 12 and t equals 20? So they're extending out past the table here. So I need some way of representing this. Right? 2,400 games per week at t equals 12. Right? And I want to know a total amount from a given rate. I have to integrate that. So R of t, this is going to be our new rate. I'm just making up a name here. They didn't tell me to call it that. R of t will be my 2,400 games per week at t equals 12. That's where we start. And then it's increasing at a constant rate of 100 games per week per week. So that's the slope. That's 100. And then I have to put in, right, my x minus x1. This is like a point slope form equation of a line. So my starting point is 12 comma 2,400. So the equation really would have been y minus 2,400 equals my slope 100 times t minus 12. I'm just using r of t instead of y, and I'm moving the 2,400 over to the other side. So now I want the total of this, so I'm going to integrate that rate of change, and I'm going from t equals 12 to t equals 20. All right, now I'll set that up at the bottom there. It's a little bit small at the bottom right, but based on this model, the total number of games that will be sold between t equals 12 and t equals 20 is that definite integral, and you can do that here on the calculator if you need to. That's pretty easy to do. All right. And finally, part D. Another salesperson believes the best model for the rate at which games will be sold in the 8 weeks between t equals 12 and 20 is that m of t function. And that's in games per week. Based on this model, how many total games to the nearest whole number will be sold during this period? And this one's just a straight, write that integral there from 12 to 20. Okay, you're going to get that number on your calculator if you use Math 9 or you use the integral feature on the Desmos embedded calculator. And just use the words of the question. Based on this model, the total number of games that will be sold between t equals 12 and t equals 20 is 15,784. Remember, you got to round it to the nearest whole number. They actually tell you that in the question. However, with a game, with something that would be destroyed if you divide it into decimal portions, you have to use whole numbers. All right, and that is question number 2. We'll look at the next 2 free response questions in the next video.